All right, so thank you all for joining us today. My name is Nick Lusson, and I work with Jubilee Bros Solar, and I am based in Nairobi, Kenya. And today we are going to be talking about different types of battery chemistries, because especially for the solar industry, this is relevant because there's so many different types of batteries on the market, and it's really difficult to make sense of all of these sometimes. I'm sure you've probably heard of lead acid batteries. Perhaps you've heard of lithium-ion batteries. Perhaps you've heard of other types, nickel cadmium, nickel magnesium, molten sulfur. These are all different types of battery chemistries. Now, we won't be able to speak to all of these types of chemistries. We've just highlighted a few that are important. Someone is saying there's no audio. Can everyone hear me? You can hear me. Okay, great. So I'm just going to continue. So yeah, we can't speak to all of the battery chemistries, but we're going to try to give you a good basic understanding. We're going to put it into context. We'll talk about the battery market globally, and then we will help you understand the different options that you have for your energy projects. So it sounds like a lot of you can hear me and a few of you can't. So I'm sorry if you cannot hear me. It might be your own settings. Everything looks good here on my side, and many people have told me yes, they can hear. Okay, before we begin, in the chat box, I have enabled Q&A mode. If you have a question, please type it in the chat box and mark it as a question. If you do this at the end of my presentation, I can go through all of the questions very easily. So if you have a question, please type it in the chat box and mark it as a question, and I will answer them at the end. So to begin, I'll tell you a bit about Jubilee Bros. We have been in business for over 45 years. We were founded in 1977 in Lebanon, mainly as a diesel generator company. And you can see on the timeline there, we grew very rapidly into UAE and Dubai, Nigeria, which is now one of our largest operations with around 1,000 employees. Also to Afghanistan, Kuwait, Ghana, Qatar, Uganda, South Africa. And in 2017, we founded our solar division, and we continued our expansion into Pakistan, Kenya, and hopefully more in the future. So in the solar division, you can see actually globally, solar and diesel. This map shows you our global logistics reach. So everywhere that you see a map or a flag, we have a distributor or a sister company or a customer. So you can see we have quite a global reach. Now we have 6 activities that we do to support our partners and customers. There they are on the screen. The first one is product supply, which is easy. We can supply high quality products. Number 2 is training. We do lots of training on a wide variety of topics. Training like this one, and definitely on any of the products, definitely any of the products we sell, we can do a training on that product. Also engineering support. So this is pre-sales support. This is, we can look at your designs and make sure nothing is missing, nothing is duplicated, and that everything is optimized. The fourth is leads, because we don't do a lot of EPC work. We really focus on these 6 activities here. So if we get inquiries from the end user, we're happy to pass those along to our qualified partners. The 5th one is referral to finance. So we don't have in-house financing. So oftentimes we know that financing is a big obstacle in the solar industry especially. So we have partners who are happy to help finance your projects to help get them across the finish line. And the sixth pillar is after sales support. So this is commissioning support, warranty support, troubleshooting support, basically all the after sales support. And in the solar industry, we are a partner of Huawei. We are a tier 1 partner, VAP, value added partner. So this means we are certified to handle inquiries up to 100 megawatts. And we are the partner of Huawei in East Africa, West Africa, Southern Africa, and parts of the Middle East. We are also CSP certified. This means Certified Service Provider. So this means we are trained and certified for all of your Huawei service needs. And this is important because not all of the VAPs are CSPs. So we're here for your after sales needs. So now we can begin the presentation, and we are here to talk about batteries, and we're going to help explain to you some of the confusing aspects of the different batteries that are available on the market. So the first thing to think about is, what is a battery? And there's many different types, and it's more complicated than you may think, because we're not only talking about a battery cell. So on the screen there are 5 different broad categories of batteries. And basically a battery is something that can store energy. So the first category is mechanical. So these are mechanical devices that store energy. So for example, pumped storage hydro. This is a dam, a hydroelectric dam. And when there is water behind the dam, it's a battery, because that water represents energy, because you can release the water through the dam and it generates power. So this a dam is effectively a battery. And pumped storage hydro means you can pump water up into the upper reservoir, and then you store it. So it becomes a battery, because the water behind the dam represents stored energy. You can release it and generate energy anytime. Another mechanical type is compressed air storage. So this is typically when they use caves or mines, something underground, and they can pump air inside that, and it becomes highly pressurized, it's compressed. And this is stored energy, because when you release the pressure, you can spin a turbine and get power. Another type is a flywheel. So these are just anything that spins, and the inertia is energy. So I'm sharing you this because perhaps you didn't think of these types of things as batteries. But it's important to realize that there's mechanical ways to store energy. Even gravity batteries exist, where you use energy to lift something heavy, and when you let it fall, it releases the energy. These are batteries. So the second type is electrochemical. This is the type that most of us think of when we hear the word battery. This includes all of the small batteries that we put in our toys and our electric devices. It includes the lithium-ion batteries in our phones and our laptops. So this is the most common type that we think of when we hear the word battery. There's also electrical batteries. This does not rely on any chemical process. They are purely electrical. And mainly they are in the form of capacitors and supercapacitors. So we will talk about these briefly later on. Now, chemical batteries rely entirely on chemical processes to release energy. And this would be like a hydrogen cell, because the hydrogen works on when you combine it with water, you release some energy and you produce water as the output. Or sorry, you combine hydrogen with oxygen. It's a chemical reaction. It releases energy. and it produces water as the output. So this is a chemical type of battery. And the last one is thermal. So this is heat. A very common type, or maybe the most common type, is molten salt. So we'll show you images here of all of these types, just so you understand. So this is mechanical. We're talking about the pumped storage hydro, or the compressed air, or gravity batteries, and things like that. These are mechanical batteries. These have been around for thousands of years, and they're very common. In fact, pumped storage hydro is the most prevalent battery in the world. Electrochemical, as I've said, this is the one that you probably know the most. You see all of these probably look familiar, and we're going to talk about these a lot today. These include lead acid batteries and lithium-ion batteries. So these are typically what we think of. There's an electrical component and a chemical component. These are supercapacitors. And if you are an electrical engineer, you're familiar with this term. A capacitor is something that stores energy in the electromagnetic field. So these are supercapacitors, and we'll talk about this later. This is a hydrogen cell, just showing you kind of what it looks like. It's a chemical reaction that releases energy. So it doesn't have electrical components. It doesn't need the electrical components that you see in the other batteries. And this is a thermal example. This would be CSP. This is molten salt. So all of those, the big circles are mirrors, and they are pointing all at that shining point. And they're reflecting the sun's light directly at that shining point. And you have a block of molten salt there. And it becomes very, very, very hot, but it stays hot for a long time, and you can use this to generate steam even at night. So that's why it's a battery. Okay, now this is a graph. All of you will receive these slides after, so some of this is useful, but it may be difficult to grasp right now on a short presentation. So this graph is trying to show you where each type of battery is useful. So on the left side, you have the power generation that is required. And across the bottom, we're showing you how long it can store the energy. So this might be confusing for you right now, but if you look at this later, I'm sure you can find it very helpful. It basically shows you, for example, pumped storage hydro at the beginning, at the top. It's only useful on very large scales. You can't have this pumped storage hydro in your home. It won't be very efficient. And on the left side, you can see supercapacitors. Supercapacitors are very good at discharging quick bursts of power. They're not good at storing energy for seasons, for example, on the right side. And you can see electrochemical batteries are in the middle, and they occupy a broad space. So that's why electrochemical are so versatile and so common, because they can be used to store energy for a few minutes or a few days. You can use them with small systems and pretty big systems as well. So the electrochemical is very efficient and versatile. Now let's look at the global battery market, and we're talking about electrochemical batteries now, since, as I've said, they're very versatile and common. So in 2020, the global rechargeable battery was valued at $90 billion, and it's projected to reach $150 billion in 10 years. So it is growing very fast. And this graph is showing you which batteries are growing and how they're growing. The blue columns are 2020. The orange columns are 2030. So what you can see here is that lead acid batteries have been the most popular type, and they will continue to be the most popular type from 2020 to 2030. They're the most lucrative segment, the largest, and it's going to continue to be that way. But you can see lithium ion is also growing significantly as well. And there's other types. The NiMH is nickel magnesium, the NiCd is nickel cadmium, and those are other. So these are all electrochemical batteries with different compositions. So the popularity, the reason that lead acid batteries are growing so fast is because they are increasingly being used in electric vehicles. However, also lithium-ion batteries are used in electric vehicles. And lithium-ion batteries are used in the high-end vehicles like the Tesla and all these BMW electric cars. And the lead-acid batteries have always been used in cars. Lead-acid battery is like a car battery. If you've ever seen a car battery, it's a lead-acid battery. But now, with advances in technology, they're also being used as an electric motor in the vehicles. And this is because lead-acid is cheaper than lithium-ion. So lithium-ion is in the high-end vehicles like Tesla, and the lead-acid batteries is more and more being used, perhaps in tuk-tuks and across India in the electric transportation segment there, and things like this. So it's growing very fast because of electric vehicles for lead-acid and lithium-ion. So let's look at lead-acid batteries. But first, let's define a few words here so that it helps us understand the pros and the cons. So these are four terms that's going to help us compare batteries. The first one is cycle. So what we mean by a cycle is charging and discharging one time. That is one cycle. So typically, we talk about cycles when we're talking about the lifespan of a battery, because the number of cycles is intimately tied with the performance of the battery. So typically, when we don't speak of battery life in years, we speak of it in cycles. And even if we speak about it in years, it's because we're estimating the number of cycles in that time. Generally speaking, the batteries degrade with cycles, not just over time. So the cycles, when you charge and discharge, that is a cycle. And this is what we talk about in the lifespan of the battery. So specific energy, this is the energy unit per mass. So energy, we're talking about kilowatt hour, okay? This specific energy is also known as energy density. So what we mean, specific energy, is how big your battery needs to be to store kilowatt hours. If we say a battery has a high energy density or a high specific energy, what we mean is in a small space, you can store a lot of kilowatt hours. That means energy density. And if we have a bad energy density or a poor energy density or a low energy density or a low specific energy, this means you need a big space to store the same amount of kilowatt hours. Okay? Now the next one is similar. It's called specific power. So this is the power unit per mass. So we're talking about the current now. We're not talking about energy, which was kilowatt hours. Now we're talking about the current, which is amperes. So the amps per size. This is also known as power density. So the same idea, it's how much space do you need to achieve a certain current, to achieve a certain power output. So a high power density means you can get a high current from a small volume, a small mass. And a poor specific power means you need a big piece of equipment, a big battery to get the high current. And the last one is depth of discharge. So basically it's expressed as a percentage of the total battery capacity. And generally speaking, when you discharge a battery to completely empty, it shortens the life of the battery. So batteries usually have a rating for their depth of discharge, and it will tell you this is basically the usable energy that can be stored within the battery. You don't want to exceed the depth of discharge. Um, yeah, so these four terms are going to help us compare the batteries now. We have cycle, specific energy, specific power, and depth of discharge. So now that we understand those terms, we can look at the batteries themselves. So these are the four types of batteries we're going to focus on today, because I couldn't present all of the battery types. So these are the four types that are most relevant to you. So the first is lead acid. This is the most common battery. I'm sure you've all seen this battery. It's car batteries and so on. The next is lithium ion. This is relatively new. These are mostly in the high-end electric vehicles, and also now for solar home systems, also now for utility scale grid systems. You can get 100 megawatt hours and so on from these. They can be containerized and very big. So this is the lithium ion represents a new trend in the market. Now, supercapacitors is also something new, and I'll explain that to you. And simply because in the end, we want to land on lead carbon. Lead carbon is something, a new battery chemistry that not many people have heard about. And it's related to these three before it. So we've chosen these four types of batteries because they are very relevant. These are the most common that you will need to know in your daily affairs. And I think you're going to get some very good information here. Okay, let's start with lead acid. So there's some images there that you can see. They probably look familiar. Lead acid comes in many different types. There can be sealed gel or VRLA, valve regulated lead acid, or flooded batteries. So these are the most common battery used in solar systems. So the main advantages of lead acid batteries, first of all, is the low cost. These are quite cheap, relatively cheap, and they're simple to manufacture. And they've been manufactured for many years. So the supply chains are mature, the factories are mature, so the manufacturing process is relatively easy. So they also have a high specific power, which means they can reach pretty high currents from a small battery. So you've probably seen these batteries. Typically, the most common is probably 12 volt, 200 ampere hour, something like that. But they come in many different voltages and different ampere hour sizes. So you get a relatively good performance across the temperature spectrum. They shouldn't be too hot though, but they're not so sensitive like other types of batteries. Also, the recycling can be done, which is a good thing. You can recycle these batteries at the end of their life. And also, they don't require block or cell management systems. So this is a bit technical, but basically they can be discharged and charged easily. You don't need complicated battery management systems. So this is generally what it looks like, just to help you understand. So there's a protective casing around the outside. You have a positive terminal and a negative terminal. And inside, you can see there, basically there's the positive electrode, which is lead dioxide, sorry. The negative electrode is lead, and then you have some kind of acid. So this is the concept. You have a positive electrode and a negative electrode, and it's in an acid, and this allows the ions and the electrons to flow, and you have a positive terminal and a negative terminal. So it's pretty simple, and this is the most common type. This is in traditionally all cars, all gas-powered cars. So here's a slide showing you the advantages and disadvantages. So as we've said, the advantages are the manufacturing is easy, it's relatively cheap, it's able to have a high current, so it can give you a high power from your small size. The temperatures is not a huge issue, and you don't need complicated battery management systems. The disadvantages are the low specific energy. So if you need a lot of kilowatt hours, you need more batteries, and they're heavy. Also slow charging, these charge slowly. So yeah, you could take a full day of solar energy, 10-14 hours to charge these. So when you're storing them, you have to be careful that you store them with charge. Otherwise, something will happen called sulfation, and this will damage your battery. So you have to store them a bit carefully. Also, the limited life cycle. So we talked about the word cycle. So typically these could have maybe 2,000 cycles. Maybe you get up to 5,000 cycles with a good one. But when you think about this, so a cycle could be one day, right? Especially in a solar home system. You will charge it all day and discharge it at night. That's one cycle. So if you have 2,000 cycles, how many years is that? We're talking about 6 years, 5 years maybe. And the truth is, I've seen that they don't always even last that long. Typically, they last 3 to 5 years. So generally, that is like 1,000 to 2,000 cycles. Some manufacturers will tell you more than that, but it's not what I have seen. So also, some of them require maintenance. Some lead-acid batteries require maintenance, and they aren't very good for the environment, especially if they leak or something like that. Okay, so now let's talk about lithium-ion. Now, lithium-ion represents the next step forward. So lead-acid has been here for a long time, and we've seen it a lot. And lead-acid represents the next significant step forward. And you can see some pictures there. So now in recent years, this is probably the preferred option for home systems. There's some real advantages that lithium-ion can offer. So the example, a few of them are the energy density. This means you can have more power stored in a smaller space. With lead-acid batteries, you will have to have many batteries, and they would be connected in series, and it can take a large space in your home. The lithium-ion batteries take up a much smaller space for more energy. Low self-discharge rate. This means that they hold if you don't use the battery, it can hold its charge for a long time. It doesn't discharge itself. Low maintenance. There's basically no maintenance on lithium-ion batteries. And the long cycle and extended life. So lithium-ion batteries can do up to 10,000 cycles, but really we say around 4,000 or 5,000 cycles. So lithium-ion, we expect it to last 10 to 12 years easily. So you can even get a 10-year warranty on your lithium-ion batteries. So this is much better than lead-acid. Lead-acid, typically we're looking at 3 years, generally speaking. Lithium-ion, we're looking at 10 years. So the lifespan of lithium-ion is about 3 times the lead-acid. So also lithium-ion has been decreasing in price very steadily over the years. So by the way, lithium-ion is the battery that's in your cell phone. and in your laptop. These consumer electronic devices almost always have lithium-ion batteries. So the price of lithium-ion batteries has really come down, similar to the way solar panels has done in the last 10 years. The main reason for this is electric vehicles, because this provided a real incentive for manufacturers to invest in the factories. So that's what they did, and especially Elon Musk and Tesla, they really unlocked this market. That by spending, a couple $1 billion on the manufacturing side, it really brought down the price of the lithium-ion battery. And this is the most popular battery for, I wouldn't say the most popular, but it's very common in electric vehicles. So like we said, Tesla and the electric car manufacturers, even the electric motorcycles, lithium-ion is very good because it can store energy in a small space, and it can charge pretty quickly, and it has a long lifespan. Now, recently, we are seeing prices go up, and this is because of the price of the raw materials. So overall, prices are going down, but currently prices are going up, and they will probably go up for the next year or two before they come down again. So this is the chemistry inside a lithium-ion battery. Basically, very similar to the lead acid in concept, except instead of lead, we're using lithium and lithium ions. So we have lithium ion on the positive side, lithium metal oxides on, on the positive side, and lithium metal ion on the negative side. You have electrolyte, and you have an ultra film that allows the ions to pass back and forth, depending on if you're charging or discharging. So the pros, here's pros and cons. The pros of lithium-ion battery, there's no maintenance. They have a high energy density, so you can store a lot of power in a small space. They have a long life cycle, so a long lifespan, probably 10 years or more. And they have a higher depth of discharge. So this means you can use almost all of the energy that you store. Some have 100% depth of discharge. You can use all of them. Some have 80% depth of discharge. Lead acid batteries, typically 50 or 60%, around 50% depth of discharge. So you can only use half of the energy you store in a lead acid battery. Lithium-ion battery, you can use all the energy. So the main con of lithium-ion is the price. This is the main obstacle. They're quite expensive compared to lead acid. There's also a chance of fire with a thermal runaway with lithium-ion. When a lithium-ion battery catches fire, it cannot be put out. You have to let it burn itself out. There's nothing you can do. You just make a perimeter and let it burn for a few days. So they can be dangerous and they can explode sometimes. This is why airlines don't like to have certain types of lithium-ion batteries on the airplane, because if they explode, they're quite dangerous. But this is actually it's a small danger, very small. Lithium-ion batteries are safe. This is only a very extreme circumstance when they're dangerous. The main con is the price, really. The rest of the obstacles are not that significant. You have to have a battery management system though here. So you need to have the right equipment with your lithium-ion battery to make sure that you're charging and discharging correctly. So now let's talk about supercapacitors. Now this is a bit different than everything we've talked about so far. So supercapacitors, these are purely electric components, and they're typically storing that energy in the electromagnetic field that is around these components. So magnetism is what we're using here. The electromagnetic field in the air is going to store the energy. So Yeah, so a supercapacitor is something like that. And there is no chemical process in these at all. So, yeah, basically this slide is talking about the composition. I'll share these slides with you and you can read this if you like. But the most significant advantage of these is that there is no degradation. There is no power degradation. So if you have a 3-volt capacitor today, in 20 years, it will still be a 3-volt capacitor. Lead acid batteries and lithium-ion batteries degrade over time. And so a supercapacitor, we say it can have 1,000,000 cycles. 1,000,000 cycles. So this is extremely long life. Much longer than all the other types. So yeah, these are some of the advantages. So they also charge very quickly, but the problem is they also discharge very quickly. It's hard to discharge the power slowly. So supercapacitors are very good for quick bursts of energy. And if you can charge them frequently and discharge in quick bursts, this would be the best use of a supercapacitor. So a great example is in Switzerland, because they have a fleet of buses. Okay, these buses, they charge many times throughout the day. Almost at every bus stop, they charge for like 1 minute. And this 1 minute charge is enough to fill the supercapacitor. But then it discharges very quickly. So they need to recharge often. But this represents a good example of how a supercapacitor can be used. You charge it frequently, you discharge it in quick bursts, and it can last 1,000,000 cycles. So the disadvantages, so now this slide, the top part is comparing batteries and the bottom part is capacitors. So the batteries, we've already talked about. So let's look at the bottom box, the capacitors, the pros and cons. The pros is a very, very long life cycle, very long. The pro is a high load current. It can have very, very high current out of this device. And another pro is the short charging times. You can charge it in a few minutes. And it performs well in all temperatures. So the cons are low specific energy. This means if you want a lot of kilowatt hours, you need a massive size of supercapacitor. Also, it's a linear discharge voltage. This means it's hard to discharge slowly. It wants to discharge very quickly all at once. It also has high self-discharge. That means if you leave it unused with a full charge, it will slowly discharge itself. And these are very expensive too. These are quite expensive. So they have some good uses and some bad uses. They're not going to replace lithium ion in the short term. So it's just good to know about this technology. And now I'd like to show you about lead carbon batteries, because this is quite new. So this is a type of lead acid battery. It looks like a lead acid battery. However, it takes some of the properties of a supercapacitor and it uses them in the lead acid. So basically, if you can see here, you add a piece of carbon to the negative diode, and this allows you to charge much faster. So this is why we say it takes a bit of the supercapacitor technology and applies it to the lead acid. So this is showing you the chemistry of the lead carbon battery. Again, more of the chemistry inside. So basically we have improved the charging and the discharging rate several times, but also we've increased the lifespan. Whoops. So lead carbon batteries have a 10-year design life. So we say it could be like 3,500 cycles. So 3,500 cycles, If there's one cycle per day, we're looking at 9 or 10 years of a lifespan. So this is much, much more than normal lead acid batteries. The normal lead acid batteries have a 3-year lifespan. So in this way, the lead carbon batteries are similar to lithium-ion batteries. They have the similar lifespan as lithium-ion. They have the fast charging similar to supercapacitors. But the great thing is the price is much similar to lead acid. So we feel that these lead carbon batteries have a pretty significant advantage in the market, and they're very unique, and they occupy a unique space with the price of lead acid, the performance of lithium ion, and the charging of supercapacitors. Not as fast as supercapacitors, but it's faster than lead acid. So the other advantages are that it does not need a complicated battery management system like lithium ion does. There's no thermal runaway, there's no risk of fire like lithium ion. It has a very high energy density and a very high lifespan compared to lead acid batteries. And this is suitable for on-grid and off-grid because of the charging rates and the high current that it can allow. So the way we have been using this in Jubaili Bros is with this system right here. We package it with our inverter because we have tested all of this equipment. We have an R&D center in Nigeria and in Lebanon, and we have tested many different batteries, many different inverters. So we have found a combination of battery and inverter that works very well, and it has to do with the charging rates and the discharging rates and several other features. So here you can see it on the screen, and this inverter is very unique because it's very versatile. It can accept the grid and the diesel generator, the solar power, and the batteries. And this inverter also has an LCD screen, and you can connect with Bluetooth. You can see the information on your phone. You can also, the screen is detachable. So you can even put the screen up to 20 meters away from the inverter. So that's very cool for in your home. You can, put the screen around the corner or something like that. Also, the inverter has something called battery equalization, which means it discharges the batteries equally, and this reduces sulfation. So by the way, the lead carbon batteries have a very, very reduced sulfation. Sulfation is the #1 cause of damage on a normal lead acid batteries. And so the lead carbon batteries have reduced sulfation, and also this inverter has a feature that reduces sulfation. So this is another reason why we feel confident that the lead carbon batteries will last 10 years because of the reduced sulfation. And the battery, the inverter can power the load directly. The power does not have to enter the battery every time. So this is very good for the life cycle of the battery as well. The power can go straight to the load. And it has a user-friendly LCD screen and a fan as well. So basically this here is showing the features of this inverter. So now we're at the end of this presentation. So I hope that you learned a lot about lead acid batteries and lithium-ion batteries and supercapacitors and lead carbon batteries. So we know that this is not possible to explain everything on a short webinar. We hope that you have gotten some good ideas here. You can do your own research on this stuff as well. It's important. You can't rely only on a 45-minute presentation to tell you everything. But we hope we've given you some topics that you can research on your own, and you can understand how it fits into the whole market that we're talking about. That was the goal of this presentation, to give you a foundation that will allow you to do your own research, and you can sort of relate to what we've told you today, and you'll be able to understand from your own context. Okay, so I can only stay for about 5 more minutes. So I'm going to try to go through these questions as quickly as possible. I'm sorry that we had technical difficulties and we got started just a bit late. So let me start with the questions. Okay, the first one, is the molten salt power generation efficient? So actually it's very efficient. It's technically more efficient than PV. The problem is it's not the efficiency of the battery. The problem is this molten salt is very dangerous and it's very difficult to control. And so the whole system that you have to build is very expensive. And there have been some very expensive failures in this market. For example, in the USA, I believe it's in Nevada or California, right on the border, it's in the desert. There's $1 billion failure of this because the molten salt started leaking and things like that. So when you ask, is the molten salt power generation efficient? Yes, it's very efficient, but it's very difficult to use and there have been some significant failures. So that's why it's slow to pick up. Can we see the life of the batteries? I hope I've explained this a bit with the cycles. I think this was early. You asked this question early before I got there. How to optimize battery performance? Okay, I don't think I could answer this. We would need more details. This is a very broad question. Maybe if you send us a message later, we can try to answer this. So what is battery equalization? Basically, when you're dealing with lead acid batteries, it's common that we could take it as an example, 12 volt, 200 ampere hours. So you have to connect them in a series to get the right, you have to connect them in series and parallel to get the right voltage and the right current. And so the battery equalization means that you're charging and discharging equally, because you could have easily 8 batteries. So it's equalization means you're charging them at the same level, and this can extend the lifespan. Because if you're discharging one battery fully and the rest are not fully discharged, it will shorten the lifespan of your battery. Can you please share these slides? Yes, I'm going to share these slides. Everyone who is here will get these slides automatically. Can you explain thermal runaway a bit further? Basically, it is when some of the energy stored in the battery or that's in and out is going to heat up the components, and the problem is this can cause a fire. So when the batteries heat up too much, this is from thermal runaway. The thermal is running away into the the battery components, and eventually, if this happens too much, it can cause a fire. This is in lithium-ion batteries only, typically, that it's a big problem. And so the lithium-ion batteries have to have temperature sensors to monitor this, because if the thermal runaway is too much, it will cause a fire. How long can a 5 kilowatt hour lithium-ion battery last before discharge when in use? Maybe you mean before recharge, but I cannot answer this question. It has to do with the current and the amount of power you are drawing. So if you have a 5 kilowatt hour battery, it means you can provide 5 kilowatts for 1 hour, or you could provide 2.5 kilowatts for 2 hours. So it depends on your load. So I can't really answer that question. Are the lead carbon the same as nanocarbon? No, I don't think they are the same. I've never heard of nanocarbon in this context. Can you please explain bleeding of a battery? Bleeding of a battery. You might be talking of you might be speaking of when there's lead acid batteries that are flooded, and I believe the pressure can build up, and so you may need to release the pressure. Now there's something called VRLA, valve regulated lead acid, where this is automatically done within the battery. So I think this is what you're talking about, when you have to relieve some of the pressure buildup in the batteries. But maybe if you shoot me an email, we can answer this later.